Hey guys, welcome to lesson 5.2, direct variation. Our objective for today is that I can write and graph an equation of a direct variation. And what is this direct variation thing that I've said multiple times now? Well, it is a proportional relationship, which is something you probably worked with a lot last year. It is a relationship that can be represented by a function in the form y equals kx, where k is not equal to 0. Our constant of variation, otherwise known as proportional constant, is for any direct variation, it's k. So whatever k is, that's our proportional constant. Our essential understanding, if the ratio of two variables is constant, then the variables have a special relationship known as direct variation. To determine whether an equation represents a direct variation, solve it for y. And if you can write it in the form of y equals kx, where k is not equal to 0, it represents a direct variation. So our first problem is going to be just that. We are going to identify direct variation, and we need to solve each of these equations for y. So problem letter A, we've got 4x plus 5y equals 0. So our first step is going to be to get x to the other side of the equation. So we subtract 4x from both sides. We're left with 5y is equal to negative 4x. Our next step is to divide both sides by 5. And y is going to be equal to negative 4/5 x. So yes, this is direct variation because k in this case is negative 4/5. Okay. And let's just make sure the x is not necessarily in the denominator. Let's just make sure it's off to the side. All right, so be careful with that, guys. Your x should either be in the numerator or just next to your fraction. Just careful that it doesn't show being in the denominator, because that'll be a whole different thing when we deal with chapter 10 and 11. All right, letter B, does 2x plus 3y equals 6 represent direct variation? Well, let's solve it for y again. So we're going to subtract 2x from both sides. And we're going to be left with 3y is equal to negative 2x plus 6. And now we're going to divide both sides by 3. So it means we divide every term by 3 on the right. So y equals negative 2/3 x plus 2. Does that look like y equals kx? Nope. So it is not direct variation. So now I want you guys to try letters A and B, and we'll go over them. So for letter A, we need to start by solving our equation for y. So we're going to add 5x in this case to both sides of our equation. 3y is equal to 5x plus 4. Divide both sides by 3. And we've got y is equal to 5/3 x plus 4/3. Is that direct variation? Nope. All right, letter B, does 4y equals 5x represent a direct variation? Well, let's get y by itself, so we need to divide both sides of our equation by 4. And y is going to be equal to 5/4 x. Yes, that is direct variation. So one way of seeing it, guys, if you have any kind of a constant in your equation, it is not going to be direct variation because you have a constant. Any kind of a constant. And it could even be when we're up here in our equation. This is equal to 0. There's no constant there. But this one is equal to 6. We do have a constant there. So you could see right off the bat that we are not going to have a direct variation. All right, problem 2, writing a direct variation equation. Suppose that y varies directly with x and that y is equal to 10 when x equals negative 2. Write a direct variation equation that relates x to y, and then we also want to know what is the value of y when x is negative 15. So let's do these one step at a time. The first thing is we need to figure out what our equation is. So I know I know the coordinates, but I don't know that constant of variation or that proportional constant. So I need to plug x and y in to solve for k. So I know that y is 10 and x is negative 2. So I'm going to plug those into the equation. So 10 equals k times negative 2. Now I want to solve for k, so I'm going to divide both sides of my equation by negative 2. And we get negative 5 is equal to k. So now we can write our equation, y equals negative 5x. And we wanted to know when x is negative 15, what is going to be our y value. So we plug in negative 15 for x. So we have y equals negative 5 times negative 15. And y is going to be equal to 75. So that's our answer. And the y equals negative 5x is also our answer because we were asked to write the equation. Okay? So let's move on to letter B on the next page. For letter B, we are being told that y varies directly with x, and we want to figure out what is our constant. Now, another way that we can solve this, we're being told that y varies directly with x. We are told that it is direct variation. So we can just take our y value and divide it by our x value, because that's what we're doing each time. So 40 divided by 8 is 5. So k is going to be 5 for this problem. All right, so now we can write our equation, y equals 5x. And we are substituting in 12 for our x value. So y is equal to 12 times 5, which is 60. All right, so that's our answer, as well as y equals 5x. Want you guys to try letters A and B, and then we'll go over them. So for letter A, suppose y varies directly with x, and x is 70, or y is 72 when x is 8. We want to know what direct variation equation relates x and y, and what is the value of y when x is 13. So we're going to just do that ratio. We're told that it's direct variation. So 72 divided by 8 is 9. So our equation is y equals 9x. All right, and we're going to plug in 13 for x. So y equals 9 times 13. And that is equal to 117. Oops. Okay. All right, letter B, we've got direct variation. Y is negative 28 when x is 7. So negative 28 divided by 7. Negative 4. So we're going to plug that in for k. Y equals negative 4x. All right, and we want to know when x is negative 5 what the value is. So negative 5 times negative 4 is going to be a positive 20. So that's our answers. All right. Now, problem number 3 is graphing a direct variation. Suppose y varies directly with x, and that y is 9 when x is 3. What direct variation equation relates x and y? Well, there's 2 ways we could do this. One of these ways is we just graph that point 3, 9, and we use one of my rules of direct variation. So Mr. Wolf is putting a point at 3, 9. And as soon as he does, we'll move the page up so you can see that he put a point at 3, 9. All right, there we go. So we have a point at 3, 9. Now, what do we also know about direct variation? Well, this is a rule we teach our 8th graders, but we can possibly get you guys to think about it intuitively. If I were to plug in 0 for x, what is going to be my y value? It's going to be 0. So direct variation equations always, 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 always go through our origin. Hey, I've got 2 points. I can make a line. So I don't even need to write the equation. Haha. Now that I have my graph, I can just look at what my rate of change is here, and well, I guess I do have to write the equation because I asked you to write an equation. All right, so we can write the equation. What is my rate of change?
Wait, I'm thinking about this. It's 1, 2, 3.
Okay.
So
we're
that's going to be the bottom one, and then we're going up 1, 2, 3, 4, 5, 6, 7, 8, 9.
So 9 over 3, 9 divided by 3 is going to be 3. All right, so our equation is going to be y equals 3x. Okay. All right, let's take a look at problem B, which is going to be kind of a real-world problem. So the weight on the moon, y, varies directly with the weight on Earth, x. A person who weighs 100 pounds on Earth weighs 16.6 pounds on the moon. What is an equation that relates the weight on Earth, x, and the weight on the moon, y, and what is the graph? All right, so let's start by just finding what that proportion constant is. So we need to do 16.6, our y value, divided by 100, our x value, and it is going to be 0.166. So when we plug that in our equation, it's y equals 0.166x. All right, so now this is one where it's not super easy for us to graph that rate of change. So we're going to use that kind of trick where we're using the origin as one of our points. And we know that a 100-pound person weighs 16.6 pounds, so we can make kind of a rough approximation. You'll see that I gave you a scale already, and we're going up by 5 pounds on y and 50 pounds on x. So if we draw our line in, all right, now, two things. Number one, I want you to make sure that your line goes all the way to the edge of your graph. And what else does a good graph need? Mr. Wolf and I, we gave you some of the information, but we didn't give you all of the information. What does our graph need? We need to have labels for our axes. So the x-axis is going to be our Earth weight, and our y-axis is our moon weight. Okay, remember we do need to include units all the time. All right, so there we go. So we have another point right there for a 200-pound person. So we can make predictions then based on how much somebody's going to weigh if we know what they are on Earth. All right, why don't you guys try letter B, or A and B, and then we will go over them. So, suppose y varies directly with x and y equals 8 when x is 4. What direct variation equation relates x and y? Okay, so let's plug this in and figure it out. We've got y equals kx. So we know 8 is our y, 4 is our x, so 8 divided by 4 is 2. So our equation is y equals 2x. So we have a point at the origin. We can start there. And we are going up 2 and to the right 1 every single time because our slope is 2, and we can use that. So now we're going to draw our line in. Remember, it goes to the edges of our graph. And there we go. Make sure you guys are using a straight edge when you are drawing these lines in. Make sure you use a straight edge. Okay? All right. And we can move on to the next question. So, another example of direct variation is when we are looking at values of money and the exchange rates. So suppose $1 US is worth $19.20 Mexican pesos. That is the actual exchange rate as of the other day. What is the equation that relates US dollars, X, to Mexican pesos, Y, and what is the graph? So our X value, we're going to do 19 divided by 1. 19.20 divided by 1, which is just 19.20. So our equation is y equals 19.20x. And now we can graph it. So we know that $1 is $19.20. Well, we should probably label our graph. So x is US dollars and y values are pesos. And we can pick a couple points that we can graph here. So if we went with, we've got $1. Well, let's go with $5. Okay. So if we're going to do $5 and we multiply that times 19.20, we get 96. So we could put a point at approximately 596, so right about there. All right. And if we've got we could use the point 10 too if we want, but we got 2 points, so we can draw a line. Okay, so now let's see how good of a job we did. If we had $10 changing to Mexican pesos, we'd have 192, which is right about where we crossed our line. So we're going to get to the right ballpark. All right, last set of problems we have are problem number 4, writing a direct variation from a table. So first we need to figure out, is it direct variation? And the way we're going to do this is we are going to take our y value and divide it by our x value for each one. And if we get the same number, then that is our direct variation constant. So we're going to do y divided by x. So 2.25 divided by -3, type that into your calculator and you're going to get -0.75. -0.75 divided by 1 is going to be equal to -0.75. And -3 divided by 4 is -0.75. So yes, our proportional, this is direct variation. We do have a proportional constant, and it's a -0.75. So our equation is going to be y equals -0.75x. Don't forget the negative sign.
Oops.
There we go. Okay. Letter B, for the table, does the value vary directly with x? So 7 divided by 1 is 7. We've got 10 divided by 3. Well, that is 3.3 repeating. And 13 divided by 5, well, that's 2.4, 2.6. Yeah, that's not going to be direct variation. So there's no equation that we're going to write there. It's still a linear line. We'll get to that later. All right. Letters A and B, I want you guys to try them. So for the data, we're going to do the same thing. We're going to divide each term. So we've got 9 over 2, which is 4.5. We have 15 divided by 4, which is 3.75. And we have 24 divided by 7, which is 3.43. Nope, not direct variation. Letter B, so we're going to do 5 divided by 2, which is 2.5. 15 divided by 6, well, that's 2.5. And 25 divided by 10, that's 2.5. So our equation is going to be y equals 2.5 times x. All right. Last page, make sure you guys fill out your level of understanding and write down any questions you may have come up with during this lesson. We'll go over them tomorrow. And make sure you write down your summary of what we learned in this lesson. So how do we find direct variation? That's all for today. Have a great night, guys.